let's get into it. And this afternoon, I'm going to be talking about the greatest cause of headaches, plant downtime. So we know that in terms of plant downtime, the greatest cause, especially in material handling equipment, is wear. So equipment wear is the biggest problem, and I can tell you this, on plant availability, the nastiest part is that it follows Murphy's Law. What can go wrong will go wrong. So let's talk about that. How do you address that? Because you want to achieve two things. You want your plant, you want your maintenance to be planned, and you want it to be predicted. You want everything to go according to plan. So I'm just going to touch on your piping systems, your conveyors, especially the leggings, and your transfer chutes. Right. So for these three types of equipment, you want to make sure that before you even start your plant, you want to make sure that your design features are on point. The design is right, and it's going to reduce wear. Or if wear is inevitable, it is localized and it is minimized. That's what you want to achieve. And also on your predictive maintenance, you want to use some electronic and physical systems just to gauge the extent of the wear that has already occurred in the equipment, so that you can tell that now we have to change this part of the equipment. So you have your condition checking, you have your trend monitoring, and also on preventative maintenance, and hopefully not corrective maintenance. You want to make sure that you use something like modular systems so that you have your acute points or your high stress points targeted, you know them, and you're going to address them when you do the maintenance. Right. So for the piping systems, how do you reduce downtime? Design features, which is going to be the bigger part of my talk this afternoon. You want to have wear-resistant ceramic linings because they have high hardness, and also you can work around the fracture toughness in case you have high impact in your process. You also, now for the pipe systems, we have a system which we call the pig eye system. It's a system which you can put, rather it's a piece of instrument that you can have through a pipe, and it goes through just checking your points, the ceramic linings that you would have put in you would have lined your pipe with, and it's going to be looking at the profile of where that your ceramics have gone through. We also have what's called the green dot system. This system works in a similar way, but it's more of a physical system. It's when the piping system, or the way the lining in the pipe is being worn off, the green dot, which is also a ceramic, is also being worn off until it gets to a point where it gets red, because it has a red ceramic underlying the green dot, the green ceramic. So when it gets to that point, you know that things are not right. You have to do the maintenance. And we have, like I said, the modular relining of equipment. Right, in this slide, I have two types of pipes that you normally find in your process. You have your pipes that have smaller diameter. In this case, we're looking at something that is under 150 NB. And for this, which is the one on the left, let me get my pointer. All right. The one on the left, which is the black one, is the one where you can have a sleeve type of ceramic lining. And this sleeve ceramic lining is specially designed for or custom made for that particular pipe. And on the right side, you have bigger diameter piping. For that type of piping, you want to have ceramics that are individually lined. And for this, they normally referred to as pipe tiles, and they're specifically designed to follow that radial configuration of the pipe. Here in this video, I'm going to show you the system that you can use for predictive maintenance, which is the peak eye system. Right. You have that yellow instrument. It goes through the pipe, and it takes a video of the lining in your pipe, and it highlights the points that are going to need attention. Right there, you see that black big hole. That's the part where you want to attend to in your piping system. Right. So you can do this. You can inspect the pipe condition over extended distances up to about 80 meters without any break in the pipe, and that will help you. You have shorter shutdowns. You have no need for scaffolding or any of that, and it's a system that you really want to use for in situ piping systems. Right. Okay, moving on. In piping systems, you have those shapes or configurations where you have to change direction, the direction of a pipe. You end up having bends in the piping system. You end up having elbows. So when you're at this, when you're going to need this type of configuration in your design, you have to take care of a few items. For example, when you have an elbow, you want to address the diameters of the elbow, because that will impact, that will determine the wear that you have from impact. You want to reduce your impact wear by increasing the diameter, and you know that from the elbow, the area after that bend is the most turbulent part if you have for fluid systems. And this is the part where the greatest wear will occur as well. So you want to address that when you're doing the design. Also, on that elbow, when you have material that has to take a turn, the impact angle, like the angle at which it hits the pipe, makes the area that's encircled there the impact area, and it becomes a high stress area. So you want to make sure that the type of lining that you have in that area can accommodate the impact that you're going to have. Okay, I'll move on to conveyor pulley leggings. We know you have to move your material from one piece of equipment to the other, and the most common in any mining process or mineral processing flow is the use of conveyors. Now for the pulley leggings, you want to make sure that they're well designed. It doesn't help a lot to have a pulley that's well designed well on point, but the legging is not well designed in terms of the critical issue, which is around friction, right? So generally, when you are lining a pulley, you want to make sure that the legging, and like I said, I'm talking about ceramic features. You can have a smooth ceramic legging, you can have a studded one. And for the studded ceramic, you want to put them on your drive pulleys. Also, sometimes you can also put them in your high tension bent pulleys. This is where you don't want the slip to happen, And you can also have them on your turnover conveyors, which are also non-drive pulleys. But generally, for the smooth ceramic leggings, you want to have them in the non-drive pulleys. Now, addressing your predictive maintenance, you have systems which are also, where you can inspect the legging in situ, right? And these systems can give you real-time wear data or profiles on the legging to see, like for the smooth ceramic tiles, you don't have tiles that have fallen off, right? Because what happens with those tiles, the ceramic tiles, is you have direct bonding on the pulley. So you don't want the ceramics when they shouldn't fall off. But like I said, Murphy's Law, they might fall off. And you want the system, the real-time system, monitoring system, to be able to pick that. And you can stop your belt and have that fixed, whereby you just put new ceramic tiles on the parts that have fallen off. So you are not completely having a new legging and that sort of thing. Right, for the preventative maintenance, you can also have the individual tile attention, like I just mentioned, that you may not have to remove all the legging at once. You can address individual tiles that are on the legging. Right. Right there I have images of the smooth ceramic leggings that you can use for the non-drive pulleys. And right there we have a studded ceramic legging, and you can see the studs that are there. And also, just on this studded ceramic legging, you have the advantage that when you have material that is caught up in the studs, when you have fluid to wash, or rather some of it can be processed fluid, it will help to move the debris rather, through the grooves that you're seeing in the image. And that is quite helpful when you have the studded ceramic leggings. Right, here we have just a comparative graph, just comparing plain rubber. We know that the traditional material for leggings has been rubber, and we have had over the years improvements to grooved rubber. Still a bit of improvement in terms of the coefficient of friction, right, from just the plain rubber that used to be used. But you can see on the far right, the ceramic material, the advantage that it has, especially in addressing the slippage issues for both the dry and the wet processes. So it's undisputed, ceramics always give you the edge. Right, here I'm gonna play a short video on what I was just saying. We have the studded tiles. On top, we have the smooth tiles. You have improved traction, less slippage on the belt, and that improves the life of your pulley. And you want to go the ceramics way. That's what I can tell you this afternoon. Lastly, I'm going to talk about your transfer chutes. In that short video that we played, you saw the belts that were feeding a transfer chute. So we really have to talk about this transfer chute, also a common piece of equipment. When you are designing your chutes, you want to add some features that are going to help reduce wear. You want to add features that are also going to reduce the impact, the effect of impact on the material, the base material. So you have the likes of dead boxes, you have rectangular to round configurations, the configurations of your piping systems, and also when you are changing the direction of your movement of the material. These are the things that you want to really consider to look at. The radius of the bends, similar to what I just mentioned on the pipes. And for addressing the predictive maintenance part, also, that PGI system comes back, the green dot system. I'm going to play you another video that will show you just more on the green dot systems as well. And on the preventative maintenance, this is the part where you want to introduce the modular systems, the modular panels, where you don't have to stop everything and start addressing all the ceramic linings, the individual tiles that are on the chute. You can simply have a module where you have a group of tiles that are in one place, and you simply take it out and you put a new one. Here we're having on the left more like a traditional type of design. On the right, a design that really has the features that I was just talking about. A dead box. You have a dead box right there. I don't think you are getting all right. But that protruding square part, that's the dead box. You also have your radius, the radius of your bends from long to short. You generally want your radius to be longer or to be bigger so that the effect of impact is reduced on the system. So that's the dead box that you're seeing there. Another dead box, two of them. This dead box work by the principle of capturing material. So you have material that will overshoot the plant trajectory, right? So it's gonna sit in the dead box. But that will give the advantage that more of the material that will overshoot the trajectory that you'll be looking at will come and sit on top of the already accumulated material. So that accumulated material will act as a buffer so that you don't have direct material hitting the steel that is underneath. Right, you can also do the rectangular to round configurations. If it's rectangular, the wear is greater, it's gonna be greater. But if you have a round configuration on the chute, it's gonna be helpful in minimizing the wear on the steel and also on the lining. So you want to, in cases where the rectangular design is inevitable, you want to be able to make sure, you want to be able to have that option of transforming from your rectangular to the round. If you really have to go back to the rectangular, it's okay, but you still have the round part. Here we're having a piece of equipment which was made by the Multotec wear lining company. And it's showing just what I'm talking about, rectangular to round. At the end, right inside, you have a rectangular configuration. On the outer surface, which is closer to where you're looking at, you have the round part. Right, I'm gonna play this video in conclusion. It's showing the modular design that I just talked about. And here we're having a fully modular chute. Everything comes ready to just assemble, to just assembly. To just assemble. So you have your panels. We have panels, and also we have demo panels at the back of this setup, where you can see the panels that you can use for such chutes. Also, again, just to recap on the leggings that we talked about earlier, this is what you want for when you are taking care of the designs for material handling equipment. You want to have modular designs. Like I said, you have the panels that are showing. These panels can come as magnetic panels, meaning you just clamp them. You can also have the ones that are studded, where when you are installing them, you have to bolt them up, which are called bolt-on quick fit panels. Usually, they come with the ceramic in a polyurethane composite panel. So you have, they're normally called a wafer design. And it's gonna help, especially for vertical applications, to reduce the impact of impact, or the effect of impact rather. So that's basically it.